These are the frequently asked questions for Algebra 2 for the 6-1 worksheet. And as you guys were working through class, there wasn't a lot that I thought I would go over with you. There seemed to be some spots where I thought just maybe, like number 22. Several people had asked about that one. And again, what we do is we separate the numerical, the number part, from the variable part. And we can do that because that's multiplication that's underneath there. So whenever there's multiplication or division inside those radicals, we can split things up. So the square root of 121 is going to give me 11. And I just treat that like a normal number. It's the square root of 121, it's 11. But the index, when I go to take the square root of y to the 10th, is a 2. And our shortcut for doing these would be to just divide your power by your index. So 10 divided by 2 is y to the 5th. And that brings us to the part where we have to figure out if we need absolute value bars. So I looked at the problem originally and I see that it's a square root, so I know I need to investigate this a little further. And I go to y to the 10th, and I realize that even if someone had put a negative value in for y, say -1, it was going to be raised to the 10th power. So the answer would always be positive. So the intent of the writer of this problem was that we would always have a positive radicand. The radicand is the number that we would have underneath that radical. So if that's the case, I can't just tell somebody that my formula is 11y to the 5th. I have to put absolute value bars around that y to the 5th because they need to know that the intent of the original writer was that only positive numbers would come out of this formula. So that's number 22. Number 26 seemed to give people some pause here. What we had was the fact that people thought, well, maybe I can separate the x and the 9 here and treat this like it's x times -9 and go that way. Absolutely not. Absolutely cannot do that. Remember, the rules say that if we see multiplication or division inside the parentheses, then we can distribute, move things around, break them apart, put them together, whatever we need to do. But this is subtraction inside those parentheses. We cannot separate that x from the fact that it's being subtracted by 9. What we can do is treat it just like it's a variable. So basically what we're doing is we're saying, all right, I'm going to put in a for x minus 9. So this will be the cubed root of a to the 3rd. Well, you wouldn't have any problem doing that because you look at it and you say, hey, it's a variable. 3 divided by 3 is 1. The answer is a. It's the same thing here. 3 is divided by 3 and gives you 1. So your answer is x minus 9 to the 1st power. And then you take a look to figure out whether or not you need to use absolute value. And this one has an odd index. So an odd index would indicate the writer of the original problem didn't have any problem with this coming out to be negative because we can find negative roots when we use cubed root. Now, we scroll down to number 27. Number 27, I do see some multiplication here, so I can break apart that square root of 25 and the square root of x plus 2 to the 4th. What I cannot do is separate that x from the fact that it's supposed to be having 2 added to it. Remember, we can break apart that multiplication, but not addition or subtraction. So the square root of 25 is 5. And then again, you just treat this like it were one variable sitting there. Well, there's our little imaginary 2 for an index. And 4 divided by 2 is 2. So it will be 5 times x plus 2 squared. Now I look at the original problem and I think about absolute value. And because they were going to raise this to the 4th power, even if someone put a -5 in for x, when you raise that to that even power of 4, it's going to make it positive. So they intended for this to be a problem that could be done in the real world. And that means that we need to make sure that our simplified form of this answer has positive answers. Well, good news. It's already taken care of because it's being raised to the 2nd power. So no matter what we get for x plus 2, it will be a positive value once it is squared. So that one does not require absolute value bars. Number 30, this one, because there is division in those parentheses, we can go ahead and separate the variable from the number. And we've done the fourth root of 81 so often, hopefully everybody is going to 3 right away with that one. So the fourth root of x to the fourth, 4 divided by 4 is 1, so that will give you x to the first. And now you have to think, should I put absolute value bars on here? Well, when they originally wrote this problem, they were going to raise x to the fourth power. So even if somebody had put a -1 in for x, what you have for a radicand is going to come out positive. So the person that wrote this intended this to always have positive answers. So down around our x, that's an x to the first. If somebody put a negative value in for x, it would have a negative answer. And that is not what was going on when the person originally wrote this problem. So we need to put absolute value bars on there to make sure that they only use it for positive values. Then number 31. Again, this is multiplication, so we can go ahead and split these. Square root of 36, 6. Square root of x squared, 2 divided by 2 is 1, so that's x to the first. 6 divided by 2 is 3, so that's going to be y to the third. And again, because this one is an even root, this is square root, we want to check out the intent of the person that wrote this problem. And I look underneath that radical and I see that they had x being squared and y being raised to the 6th power. Those are both even powers, so no matter what, they were supposed to get positive answers out of this formula. So I look at mine and I realize if somebody puts a negative in for x, this answer is going to be negative. And if somebody puts a negative answer in for y, this would be negative. So I'm going to need absolute value bars on either side of xy cubed to make sure, be absolutely certain, that this will just be used to give you positive answers. On the other side of the worksheet, we had some word problems here, and someone had actually asked me to take a look at number 34. So 34 says the temperature T in degrees Celsius of a liquid, lowercase t, minutes after heating is given by capital T equals 8 square roots of T. When is the temperature 48 degrees Celsius? All right. So when is the temperature 48 degrees Celsius? Well, it says the temperature, capital T in degrees Celsius. That's where that needs to go. So 48 is for capital T. Then what we would do is we would go ahead and divide both sides by 8, and 6 equals the square root of T. And then to get rid of the square root, you have to square both sides. And we will get 36 for T, and it said that T, lowercase t, stood for minutes. So 36 minutes is what we're looking at for number 34. It's a matter of figuring out whether or not you should use the capital T or the lowercase t. So you go back to the problem and use the given information to figure out where things should go. Then, problem number 44 looked like a good one to go over. It says the number of new customers N that visit a dry cleaning shop in 1 year is directly related to the amount A in dollars spent on advertising. This relationship is represented by the formula N to the third equals 13,824A. We want to attract 480 new customers. How much should the owner spend on advertising during the year? So you have to figure out, where does that 480 go? Well, 480 stood for new customers, and it says here in the given information that new customers are N. So 480 cubed equals 13,824A. Then you punch in 480 cubed, and you don't like what you see because it's a huge number, 110592,000. But then you realize you're going to divide both sides by 13,824. and that gives you 8,000. So $8,000 in new advertising should get them the 480 customers if that formula is working properly. Number 45, this one says the volume of a sphere, they remind you of the formula, volume equals 4/3 pi r cubed. A says, what is the radius of a sphere that has a volume of 36 pi cubic units? So I'm going to put 36 pi in for V, so that will be 4/3 pi r cubed. And the first thing I notice is there's a pi on both sides. So if I divide both sides by pi, that's going to cancel right out. So pi doesn't really affect the problem. It's going to be 36 equals 4/3 r cubed. Next thing we would do is multiply both sides by the reciprocal, which would be 3/4. And we can do a little reducing here to make things work out a little nicer. 4 goes into 36 9 times, so 27 equals radius cubed. And then finally, to undo cubing something, we use the cubed root. So the radius for A, the radius of the sphere, is going to be 3 inches. 3 inches. Because the labeling, as you look at problem A, says that that's in inches. Now problem B says, if that volume increased by a factor of 8, what's your new radius? Well, let's see, it was 36 pi, but increasing that by a factor of 8, you do a little multiplication there, and that's going to get you 288 pi. So that would be your new volume. But you would solve it the same way that we did the last one. We would divide both sides by pi and get that out. Multiply both sides by 3/4. See what we get and take the cubed root. That comes out to 216. Oops, I put a 2 up there when I was fixing my very bad looking R. There we go. And then we take the cubed root of 216, which is 6 inches. So they increased the volume by a factor of 8, and that increased the radius to 6 inches. And number 46, I'm going to clear off what I have here because I saw what could be a very common mistake that would be made on that problem. I just want to talk you through that. And that is, because it's not a tough problem. You're thinking, why is Cedar Home going to go down to 46, for goodness sake? This one wasn't hard at all. Well, it's not difficult. It's just that you have to read this carefully. It says the velocity of a falling object can be found using the formula v squared equals 64h, where v is the velocity in feet per second, and h is the distance the object has already fallen. So for A, we are supposed to figure out what the velocity is if the object has been dropped 10 feet, 10-foot fall. So v squared equals 64 times 10, which is 640. You take the square root of both sides, and we get a velocity of about 25, or change that from equals to approximately 25.30 feet per second. Then for B, it says how much does the velocity increase if the object falls 20 feet rather than 10 feet? So instead of putting a 10 in there, you put a 20 in there, and you get v squared equals, we'd have 64 times 20 this time instead of times 10, and that's 1,280. And then you take the square root of that, and that velocity is approximately 35.78. Said that wrong twice. 35.78 feet per second. And you might think, done. You know, I've got answer B. But it didn't just ask us what's that new velocity. It said the increase. What is the increase? So we have to take our 35.78 and we have to subtract the 25.30 for the original 10-foot answer, and that will give us approximately 10.48 feet per second. And that, I believe, will be the last one I'll do for you.